आज फेरि हामी डिएससीको नोट पढ्नेछौँ, जतिसम्म नोट हुन्छ त्यतिसम्म। अब 168 पाटमा रहेको रहेछ। च्याप्टर 1 इन्ट्रोडक्सन द सिस्टमेटिक प्रोसेस अफ अर्गनाइजिङ द कलेक्सन अफ द डेटा इन अदर वर्ड द डेटा स्ट्रक्चर इज द सिस्टमेटिक प्रोसेस अफ sorting, arranging and data in the computer system. Data arranging primitive, non-primitive, integer, float, char, pointer, array, list, file, linear, non-linear, stack, queue, list, tree, graph. Type of the data structure: linear data structure, non-linear data structure. Linear data structure, it is type of data structure where all the element and the data are stored in the sequential order. Since the element are arranged in the sequential order, we can manage it easily. Since the array are linear data structure, linear data structure, non-linear data structure, data primitive, float, array, list, linear, non list मा चाहिँ linear list, stack, queue, list अनि tree graph हुँदो रहेछ। stack, queue, list, tree graph. Linear data structure is type of data structure where all the element of data are stored in the sequential order. Since the element are arranged in the sequential order, we can manage it easily. Example: array, stack, queue, linked list. Array, it is the linear data structure in which the data element are arranged in the sequential order where only the similar type of data are stored. Stack, it is the linear data structure that follow the insertion and the deletion through the same side, which is top of the stack. Which is the top of the stack. It is the stack mainly of the two operand are used: push, pop. Insert the element in the stack, pop भनेको delete the element, queue. Unlike the stack, queue data structure works in the FIFO principle where the insertion is done through the one side and deletion is done to the another side. If the it works just in the queue or ticket counter. Non-linear data structure, choose the data structure where the data is represented in hierarchical tree structure. In the data structure, transfers of the data cannot be done in a single run graph. A graph consists of the node called the vertex, which is conjugated to other is eye of the vertex. The tree, it is the similar to the graph. A tree is also collection of the node in the is data structure operation. Insertion, adding the new data into the data structure is defined as the insertion. Deleting, removing the data structure from the data is referred as the deleting. Sorting, arranging the data. Sorting, finding the location of the data in the data structure is called the sorting. Arranging, combining the data structure. Two different types: transversing, visiting the every element of the data structure. At least one is referred as the transversing. The element commonly used in the printing, reading, and displaying the element stored in the data structure. A difference between the linear and linear data structure. Linear data structure used to represent the sequential data. Non-linear data structure used to represent the hierarchical data. It is easy to implement, it is difficult to implement. The basic linear data structure are the list, stack, and the queue. The basic non-linear data structure are the tree and the graph. Data element can be transferred into the single run. Data structure cannot be transferred into a single run. It is used in the application software development. It is used in the AI and the image processing. Why the data structure is important: it helps to store information, securing the computer system. It helps to assess and process the data effectively. By the help of data structure, we can transfer the element data easily and efficiently. Disadvantage of the data structure: advantage, IT computer expertise is required in offer. The disadvantage: computer expertise, it is implement, it is difficult to manage extraction of the data. Task extraction means the showing the data information and hiding its implementation. In an edit is a mathematical model of the data structure that specify the type of the data and the operation supported by the name and the type and the parameter of the operation. ADT is a type of the class for the object whose behavior is defined as the set of the value and set of the operation. The definition of the ADT is only mentioned that what is the operation are to be performed, but now how this operation will be performed. ADT is a mode of the primitive data types, but the logical operation are hidden in the size stack queue. Stack empty, push, pop. Size is full, pick, queue is full empty, insert, size, insert, remove, get, replace size. A difference between the stack and the queue stack is the linear data structure, and the LIFO principal queue is the mm, linear data structure based on the FIFO principal. Stack is the insertion, deletion, and the perform into the same in the queue. Insertion and the deletion are performed at the different in the stack. One pointer is used to is called the top of the stack. In the queue, two pointer are used. They are the from the rear in the stack operation are called the push and the pop. One queue operation are called the in queue and the DQ. It is visualized as a vertical collection. It is visualized as the horizontal collection. There is no wastage of the memory space. There is the wastage of the memory space collection of the plate of the wedding and the marriage example. The ticket counter. Application reversion, string reversion, undo, redo, balance, parenthesis, implementation of the recursion, evaluation of the postfix, prefix, push operation is used to insert an element into the stack. To insert the element into the stack, first we check whether the stack is full or not. If the stack is full, then the condition is stack overflow. Algorithm of the for the push operation step start the top max size, right? The stack is full or the overflow yields. If set the top into the top t plus one, set stack a top t value data in write the condition for the overflow top max size pop operation. When we remove an item, we say that we pop the item from the stack. When an item is popped, it is always at the top of the item. When the item is removed, it the stack as pulled, then the stack. This condition is called the stack underflow algorithm for the pop operation start. If write the stack is empty or the stack underflow, go to the step value stack top plus one in the stack plus as in edit stack in top in the stack print 5 void push void pop void display void push void max size stack overflow top one top stack top plus value infix and the postfix notation while writing the way of arithmetic operation expression is known as notation. Infix operator appears between the two operator a plus b operand prefix operand appears the before the operand parenthesis free expression. It is also called the Polish notation. For example, tab is prefix a plus b postfix operator appears after the operand parenthesis free expression, also called it a reverse Polish notation. Example ABT, the postfix A plus B postfix operation are the most suitable to calculate any expression on the computer in a university. Accepted notation for assessing the algorithm is calculated. Assessing the algorithm in fixed order of the operation parenthesis exponential right to the left multiplication and the division subtraction and the addition conversion of the infix expression to the postfix and the postfix notation a b into c infix a into b into c a into b minus c into d a into b into c infix prefix a plus b into c a plus b into c postfix a plus b into c a plus b c into x a b c plus a b into c prefix a plus b into c a plus b into c x into a plus b c postfix a plus b c postfix infix a plus b c a plus b minus c infix infix postfix a plus b into d a plus b minus c a plus bd. bd postfix a plus b into d. An algorithm to evaluate the postfix expression made the empty stack on the disk. Scan the input postfix string from the left to the right from each symbol in the input postfix string. If the symbol is an operand, push system into the stack operand to pop an operand from the operand stick, which is the top of the element. Operand pop an operand from the operand stick, which is the next top of the stick. Value result in applying the symbol of the operand 1 and operand 2, push value into the operand stick, pop value from the operand stick, which is the required result. Symbol operand 1 operand 2 symbol operand 1 operand 2 operand 1 operand 2 was set convert into the prefix without using the stack a b into c a b c d e a b c d. Write the algorithm to convert the infix expression into the postfix expression using the stack symbol stack postfix precedence a b c into d plus 1 a b c a plus b into c a b c plus d minus e symbol stack postfix a plus b a plus b a plus minus a plus b a b precedence a b 3 1 plus into 2 plus minus 1 higher lower no same operation of the same precedence can lie together associately left to the right, right to the left. Bracket pop operation bracket c plus d bracket minus c e bracket plus into plus minus c into d a into b into c into d a b c a b c d a b c d a b c d plus a b c d into e infix to the prefix, infix, reverse, postfix, reverse, convert to the prefix a plus b into c, d into e as reverse is symbol, 5a e, a, d into c plus e, stack plus minus into a, 5 5p and 5p a d, 5p a d, 5p a and 5p d c. 5p a d c e and d c e and d c b e and c d b e and c d b and CNCDBBE in reverse A1 plus algorithm to convert the infix to the postfix expression using stack initialize the stack scan the operator from the confident to the right to the infix. If the leftmost character is an operand itself, it is the current output of the postfix postfix string, and if the scan character is the operator and the stack is empty without the content, the infix symbol push and the operator to the stack. If the scan operator has the higher precedence on the existing precedence operator in the stack of the stack is empty, put it on the stack. If the scan operator has a lower precedence order, the existing operator in the stack pop L in the stack operator after that push the scan operator into the stack order if the scan element or character is not left bracket. If we encounter the right bracket post order stack print the output until the encounter discard and the both bracket in the both bracket the repeat all the stage repeat the step from the 2 to 8 until the infix expression is scanned. Scan post pop and the output all the character including the operator from the stack until it is not empty. Empty chapter 3 the q is the linear data structure that follow the FIFO principle. Main operation in the queue in q dq is full is empty size peak. In q the main operation in the queue in q dq is full is empty size peak in q dq is full is empty algorithm for the queue operation is start rear max size, then the queue is full of overflow and the got to the step height LC is rear plus one q rear data in algorithm for the DQ operation condition start front rear is equal to 1 the in queue is empty underflow then go to the step 5. The degree element downshift data q in front plus 1 in evaluation 574 minus into 84 plus in Q symbol of 574 minus 874446754 operation 17585 stack if 75753 15 8 584 15 12 4340 75 43 53 15 above 8 4 12 15 to 17 stack 57 574 53 15 15 8 584 15 2 covering the infix to the postfix using the stack p plus q r plus s p plus 1 for b into 2 symbol operator in the stack postfix p plus q r r q r s t t t u to comma u v into w t t plus minus q t c t t c t t 1 t c t t t minus into p q p q p q PQR, PQRS, PQRS, PQRS into T, PQRS into T, PQRS into T, WPQRS into T plus WPQRS into T, 4P, PQRSTWP assignment application of the queue type managing the request and the single shared resources such as the scheduling and the disk scheduling, handling hardware and or real-time system interrupt, handling the website traffic, routers and switches in the networking, maintaining the playlist in the main media player. Types of the queue: simple queue is a linear queue in the symbol queue insertion of the data text from the rear in and the deletion makes from deletion makes from the rear end and the deletion takes from the front end. Follow the FIFO principle rear front. If the major drawbacks of the using the simple queue in certain takes place only on front rear only if the first element are deleted from the queue. We cannot insert the more element even though the space is available. In this case, this shows the overflow as the rear is pointing to the last element of the queue. Circular queue is a circular queue is similar to the linear queue that follow the FIFO principle in which the last position is connected to the first position in a circular queue. From a circle, thus unknown ring is suffer 0 0 1 2 3 0 1 2 3 3 1 2 0 1. It overcomes the simple queue drawbacks of the queue. Empty space is available. The new element can be added in it. Simply the incrementing the value of the rear. It has a better memory utilization. Parity queue. It is the special type of the queue. Element are arranged based on the parity. Suppose some element have the same parity and it will be arranged according to the FIFO principle. 10, 30, 20, 15. Rear higher priority insertion in the priority queue takes place based on arrival, which deletion in the priority queue occur based on the parity. It is used in the CPU scheduling element can be inserted in an array. Tries of the priority queue, ascending priority queue. In this queue, the elements are inserted, but the deletion will take place in the smallest element. Suppose an element with the element 2, 9, 2, 6, 7, we can insert in the same way, but arranging the order will be 2, 6, 9, descending priority queue. Insertion of the element can be anything, but the deletion will take place with the largest element DQ, double-ended queue, ascending queue, parity queue, infix postfix. Insertion and the deletion can be done from the both in the front and the rear. Insertion, delete and the rear DQ. Insertion will done in the one in limitation of the queue, front queue, rear one, A B C 0 1 2 3 4 C 0 1 3 4 A B C 1 2 3 4. But necessary limitation we can insert the F, but we have the 0 in the first place, empty rear max size. So showing the queue overcome the queue element. If the queue is too large, we can use the circular queue. Application of the queue call center uses the queue to hold the people. Application of the queue system is used to handle the different tasks waiting for the printer. Algorithm for the in queue operation in the circular queue start if front rear plus one max size plus queue print error circular queue overflow gota step 4 if in front rear set front rear 0 rear plus 1 and queue rear data stop. Start algorithm for the DQ operation in the circular queue start if front print error circular queue is under the and go to the step 4 data queue in front rear set front rear minus 1 rear front plus 1 max size in queue DQ delete step front rear एउटा डेटा छ डेटाहरू छन् यी डेटा छैन front plus rear algorithm for the in queue operation in the circular queue start the front If the front if takes front rear plus one max size q max size initially an empty circular cube f1 front rear plus one max size f1 plus 2 you take a value as a 10 if front minus 1 f0 r is equal to 0 value 0 10 if front rear plus 1 max height 1 to 0 yeah, 1 into false yields take value 20 if front is equal to minus 1 yields false rear 0 plus 1 percentage 3 1 percentage 1 q rear value q1 2 q if front q is equal to rear 3 percentage q in q print overload in the let us suppose first element of the data let us suppose if front rear plus 1 percentage 3 false take the value of q if front yields rear plus 1 in q value dq the algorithm for working the dq operation in the circular key if front rear plus 1 data structure in the algorithm if it related yields data aq front rear yields front 2 percentage 320 is deleted data 30 front rear set f1 minus 1 f 30 is deleted q as an ADT. The q abstract data types is defined by the following structure and operation. The q is the structure in which the element are added in one in called the rear and the deleted in the another in called the front. It focus on the FIFO principle. The queue operation in queue insert acts at the rear of the queue and if the queue is not full, DQ remove the front item from the queue. Is full check the queue is full if the full return true otherwise false. Empty check the queue is empty if the empty return then the otherwise false. Pick if the value from the find what removing from the queue make the empty to make the queue as an empty size get the size of the queue is empty in queue dq in queue dq peak size implementation of the in data if is full return rear plus one inserting rear data return one in say implementation of the dq is empty return 0 in data queue front plus one return data linear queue is a queue in which the element is inserted as one in called the rear and deleted it and the other in called the front. Circular queue is a queue in which the last position is connected with the first position if the space is available, but the rear is pointing to the last element in the queue or we cannot insert into the element. If the space is available, we can insert the element. It has the bad words memory arrangement. It has the better memory management. It is also called the simple queue. It is called the ring queue. You have we can solve the limitation of the linear queue using the circular queue if front rear plus 1 max size b plus 3 all take a value as a 10 front is equal to front minus 1 rear plus 1 max size percentage 30 q rear data 0 10 data is inserted in this way the circular queue overcomes the limitation of the linear queue by inserting the element. Chapter 4 linked list, singly linked list, doubly linked list, start a node, linked list, null data, insert an operation to insert a node in the list, allocate the required memory to the node, assign the data into the data field, they adjust the pointer into the link, insert the node at the required place. There are the three ways the insertion of the node in the linked list, insertion at the beginning of the list, insertion at the end of the list, insertion at the specific position of the list algorithm for the insertion of the Nico code at the beginning of the list. Start allocate the memory for a new node, assign the value in data field. If the list is currently empty, assign the null and make the new pointer to point. We set the external pointer to the point a new node start as 6345 null. A new node address the field a linked list pointer next field a program structure input data can be inserted create a new node data if you start a new node next null. Next, start the new node, start a new node A, B, C, D algorithm to insert a new node at the end of the linked list. Start allocate the memory for a new node, assign the value in the data field, assign the null to the field, a link field, and the new node by default. If the list is empty, set the external pointer to the point of the new node, otherwise, transfer it to the list until the last node is reached and then insert the new node after the last node by assigning the link field last node in the pointer new node step a b c d e d null program write a p next null p is equal to next p next a new node next null p next char win code sang point alternately be step on input data to be inserted create a new node data data new node next null if start null linked list start new node step 6 step temporary start step 7 repeat the step until the next step will be set temporary next new node in the temporary is a temporary pointer to hold on the node adapter start the list a b temporary q insert the node into the specific position of the singly listed and position of the algorithm allocate the memory new node assign the data transfer the list in the field into the given node assign the link field and the new node up to the point assign the link field and the given node of the new node start a b c d three other surrounding succeeding first node second node third node succeeding preceding deletion operation it is possible to delete an item from an existing list of the three-word deletion from the beginning deletion from the end deletion from the specific position and position of the list algorithm to delete an element from the beginning of the list front of the beginning of the list start if the list is empty print list on flow move the pointer to the second node delete the first node start a b c d after node a b c d algorithm to delete the element with the end a start if the list is empty print the list is under flow transfer the list node next is null and the move the previous node and set the node last node is deleted step 6 a b c d null step a b algorithm to delete an element from the specific position to a singly listed start the holds the address of the first node set the node start if the node null then the print underflow set 1 set 2 start if the list is empty ptr null empty linear flow and stop initialize the counter and the pointer int I0 set ptr start repeat set temporary ptr plus next ptr t plus 1 set p into ptr types of the linked list singly linked list doubly linked list circular linked list singly circular linked list doubly circular linked list singly circular linked list to address field are presented in a node 1 of the link stores doubly linked list singly list linked list doubly linked list, the two address field are presented in the node. One of the link stores the address in the following node, while the next address field stores the address of the mm, address of the previous node address. The next link of the last node and the previous node link of the first node is null. Previous the node address data. Next node address is the following node. Node representation of the doubly linked list. Structural node axis and next previous node the real-time W linked list is used in the web page navigating forward and backward direction in the border. It can be used to get some card advantage of the W linked list. It allow the transferring in both forward and backward direction. Deletion of the node it can be done easily. Reversion of the linked list is easily. Insertion can be perform efficiently at the node. Disadvantage each node has extra pointer which requires the extra space. It requires the more pointer to be handled, hence it takes more time for assessing. A singly circular linked list only one address is present at a node. The address of the last node consists of the address in the first node so that the last will point the first start A, B, C, D, W circular linked list. Two circular linked lists are present in the node in one of the link is stored in the address following the node while the another stores the address of the previous node. The next field of the last node point to the first node while the previous link of the first node point to the last node is start A, B, C. Implementation of the linked list is static implementation, implement dynamic implementation of the stack using the linked list, implementation of the queue using the linked list, implementation of the stack using the link list to operation that we are applying the stack push and the pop. The push operation is similar to adding a new node at the beginning of the linked list. The stack items can be accessed only in the top, in the list item can be accessed in the front. Similarly, removing the first node, then the stack similar is popping up in the item first of the stack. The sixth case is the only the immediately accessible item in the condition. The first node in the linked list and the top of the stack. Start is the 16, 17 stack 5, 15, 16, 17 start 15, 16, 17 right algorithm to implement the stack. Implement of the queue to implement the queue in the linked list to make a first node of the linked list and the front and the last node of the rear and so we still use the pointer variable front and the rear initially when the queue is empty, the both front and the rear will be null. The in queue and the dq item will insert after the rear node and the update a rear point to the new node. The dq item we remove the front the account and update from the pointer. Then the pointer node function works similarly. Delete node plot root the enqueue front application of the linked list implementation of the stack of the queue automatic operation as long as the integer implementation of the graph dynamic memory allocation represent polynomial memory management advantages of the singly listed dynamic memory allocation. Dynamic size easy to insert a new node at any time. Deletion of the existing node is easy. Faster accessing of to the element. Disadvantage of the singly listed the memory is wasted because of the pointer required the more memory to store random access is not allotted. We have to access elements sequentially from the first node. Reverse transferring is difficult to perform list on as an ADTA linked list in the chain of the node where a node is consist of the two field the data field and the next address field data field store the actual element, whereas the next address field store the address of the next node in the list of ADT operation. Insert the element get replace size empty full is null full get stray road 9 root level degree 152 initial node 9 2 4 5 3 7 11 12 13 6 5 14 8 9 10. The tree is the hierarchical structure which is the hierarchical relationship exists dynamically several dataset items. The tree consists of the node which parent chain relationship. It is the linear data structure root. It is the first node of the Fibonacci data arrangement in the data items. Each items is called the node. Is called each item in the tree is called a node. The node that produces the another node is called the parent node from the above. Now figure A is the point parent node and the B and the C. Binary tree is a tree in which the node can have more than the two children. Typically, these children are described as the left child and the right child of the parent node. 1, 2, 3, 4, 5, 10, 2, 4, 8. A basic operation of the binary tree. Create a empty binary tree, transferring a binary tree, inserting a binary tree, deleting a new node, searching for a node, determining the total number of the node, determining the total number of the leaf node, determine the total number of the node, find the smallest and the largest element in the node, find the Height of the tree, height 1, 3, 2, 2, height 1, 4, 1, height 8, 0. Property of the binary tree, the order of the binary tree is two binary trees does not allow the duplication value. The maximum number of the node level 1 in the binary tree, the maximum number of the node in the binary tree of the height h is 2h minus 1. The binary tree with the height leaves as the basis. The types of the binary tree: strictly binary tree, proper binary tree, full the tree binary tree is elevating in the binary tree as a non-empty left or the right subtree. In other words, it can have either no children or the two children. Each node contain either 0 0 degree A B C D. Complete the binary tree. All the node are completely filled except the last node and the last level of the node completely as possible. In a complete binary tree, nodes will be added 1 2 3 4. Perfect binary tree. All the binary perfect tree is of all the tree have the two children and the leaf node are at the same level 1 2 3 4 5 2 3 6. A degenerate binary tree. All the internal node have only one child. A number of the node balanced binary tree. The difference between the height and the left subtree and the right subtree for the every node and the not more than one. It is collide in the binary tree, ABL tree and the red black tree. Height of the left subtree, height of the right subtree difference level 0, level 1, level 2. The transfers in the binary tree. It is the way in which each node of the tree is visited exactly once in the systematic manner. There are the three types of transfers: binary tree producer, visit the thread, visit the node in the left, visit the node right subtree, root pre-order A plus B. Pre-order, post-order, in plus A plus B, in order, post-order A plus B, post-order, visited once, visited twice, visited thrice, pre-order, in order, post-order, pre-order A, B, C, D, E, F, G, in order A, B, D, E, H, E, F, G, H, I, J. Construct the binary tree using the following condition: in order A, B, D, C, E, pre-order B, A, C, D, E, step 1, B, B, A. A B C D E B A B C D E A B C D E A B B D E G E F I J shortcut. We focus on the pre-order 4 5 2 6 9 3 8 4 2 5 9 3 6 rooted in order. Construct an expression of the given infix expressed A into B C plus D into P into Q. We effect the operator with the lowest precedence as a node A into B plus C, B plus C into D. The binary source, it is the binary tree which is either empty or satisfy the following condition: every node has a value, number of the two nodes have the same value, and all the value are the unique. If there exists the first child of the first subtree, then its value is less than the value of the root node. The value of the right child or the right subtree is larger than the value of the root. 50 25 75 40 30 64 45 80 85 65. Operation of the binary tree: insertion, deletion, transversing, in order, pre-order, post-order algorithm. To insert the node BST start, insert the data root info, proceed to the child of the thread, did the data, compare the data in the step insertion 5, following tree, construct the BST from the tree: pre-order, post-order, pre-order, post-order. Construct the BST tree using the following data: GUNIPERSTFB. Binary searching the ABCD. Construct the BST 30 22 15 10 35 40 49 95 8. Suburban ISTR pre-order ABCDE algorithm. To write the node to be deleted as a number of the children, simply the delete node, remove side node to be deleted as exactly one child, copy the child, the node, delete the child. If it has the left child, find the largest element from the corresponding left subtree, then they replace the longest node information with the deleted node. If it is the right children, find formality from the corresponding right subtree, then the smallest node information within the deleted node. Remove the node to be deleted as two children following the same process of the given above. Randomly select a child and find the smaller or the large node and replace with the child of the selected node. The tiles that we use the get after deleting the nodes should also be a binary sort tree. No child, delete child password, rebound the child, delete the second child, delete subtree, find the child 8, 6, 9, 10, 17, 15, 12, 14, 19, 10, 15, 8, 9, 4, 12, 94. Highest level depth balance binary tree 1, 2, 3, 4, 5, 3, 6, 7, 8. Balance binary tree ABL tree, ABL tree, ABL tree is adjacent Blacksky, GM adjacent Blacksky analysis mathematics developed algorithm in 1952. Tree is called ABL tree. It is the balanced binary tree in which the left and the right subtree and the any node may differ in height and in which the both subtree are themselves ABL tree in difference. The height is called the balance tree, balance factor height, subtree height. In order to the balance ABL tree, we use the rotation ABL tree, rotation, left rotation, right rotation, left rotation, rotation, left, right rotation, right rotation, left rotation, left, bottom, right bottom. Algorithm to insert a node ABL tree. Insert a node into the same way as a binary tree. Trace the path from the new node backward of root for checking the height difference of the two subtree. Each node along the way. Consider the node with the balance two node on the larger immediately below. The if tree node lies on the line applying the single rotation correct imbalance, this three node line and the dealing the pattern in there is the blend in the path applying the double rotation balance step construct the ABR tree step 10 3 1 0 2 3 2 1 0 1 3 condition are 1 0 1 step 1 2 3 4 1 2 3 4 5 1 2 step 6 1 2 4 5 1 6 step 7 1 2 4 5 6 7 3 1 2 3 4 6 7 5 6 3 5 11 was 8 4 1 12 7 2 6 step 3 5 11 5 3 11 step 2 5 11 8 3 11 4 5 11 12 8 7 3 4 1 2 5 11 12 1 3 4 2 5 3 1 4 2 11 10 7 6 8 step 1 20 30 80 20 30 80 20 30 80 40 60 step 3 30 80 20 60 80 20 70 B tree the self balance tree in which the every node contains the multiple key value and the more than the two children bit tree of the order degree and at the following position all the leaf node must be at the same level all the node except the node root node must have at least binary tree the binary insertion tree construct the binary tree for a 26 26 12 14 14 24 12 16 Hoffman's algorithm compression system uses the Hoffman's algorithm for the compression of the text, image, audio, etc. The general idea behind Hoffman's algorithm that uses the less number of the bit to represent the mostly used key. Hoffman's algorithm is called the lossless data compression algorithm create the sorted node frequently probability start loop find then remove the two smallest probability create a new node wait node insert a new node bank to be started list repeat the loop until the list consists of the only last node stop construct the Hoffman's tree and find the Hoffman's for the symbol A B C D E with a frequency 24 12 10 18 and respectively arranging the frequency in ascending order character frequency A C D E B A 8 8 10 12 24 100 100 1 110 111 3 bit 3 bit, 1 bit, 6, 12, 3, 8 through 22. Huffman's algorithm calculate the total number of the bit at the encode message 8383 103 to 12 3 24 3. Total number of the bit 138. Construct the Huffman's tree and Huffman's code B C D A B C D A character frequency B C D A D E frequency 56942. Arranging the ascending order character frequency code E A D B C 2234561 110 111 10 001 20, 11, 10, 2, 3, 4, B, C, D, A total number of the bit 2, 3, 3 into 3, 4 into 2, 5 into 2, 6 into 2, 45. Construct the Hoffman's code and the A, B, C, D, E, F, write with the frequency 45, 13, 12, 16, 5 character frequency code GAM3. GAM3 is a type of recursive search that examines all the possible novel of the game tree and the result in the attempt to find the optional move. Let us consider the tic-tac-toe game. Give a board position at the figure. Illustrate the figure. Possible move cross X can move from the position 001. It is possible to look ahead into the several move. We define the look ahead level as a number of the future moves to be considered. The game tree is popular by determining the best for the player during the move. Recursion is a programming technique in which the function is called itself as inside the body. Example: factorial calculation, Fibonacci series, Tower of Honey. Types of recursion: direct recursion, indirect recursion, direct A B N A C, comma A B C A comma. It is called the recursion and factorial recursion. Mathematical fact 1 by n. If n 0 n minus 1. Principal recursion, there must be the recursive call to the function. There must be the base case to concrete the solution is found in 1 in 0. Recursive calls must be coverage towards the base case algorithm to calculate the factorial of and check the whether number is equal to n1 or not. If n equals to 1, n equals to 0, base case return 1, return n into fact n minus 1 in the recursive application recursion to calculate the factorial function to determine whether the odd is over this palindrome or not to calculate the power of the number to solve the ancient tower of the Hanoi problem. Disadvantage of the recursion: consumer consume lot more storage because the recursive calls along with the automatic variation are stored in the stack. The computer may run out of the memory. Recursive call it is more efficient in terms of the speed and the execution method. If the proper precautions are not taken, recursive may not result in the non-terminating recursive and iteration. Iteration is the process in which the function used to loop repeat the sum point of the code repeatedly. The main difference between this recursive is that the recursive we use the function calls to execute the statement repeatedly inside the function body, while the iteration we use the loops like for and while to do the same program. To calculate the factorial include std.h, include conico.h, void many in fact in fact enter the value scan a percentage d fact and value a percentage gets function call in fact int x is equal to 0, x is equal to 1, return 1 yields return x into fact x minus 1. Difference between the iteration and recursion: iteration when the some set of instructions are executed repeatedly is called the iteration. When the function calls itself directly indirectly is called the recursion. Implemented using the loops, implemented using the function call. It includes the initialization condition, increment, decrement controls, file executing and uploading in the recursive function. Only the termination condition base does not use the stack. Stack is used to store the set of the value new loop variable parameter each time function is called. Every iterative method can be converted into the recursive method. Every recursive algorithm can be converted into the iterative method. Iterative code is generally bigger. Recursive code are smaller and the simpler, faster in the execution, slower in the execution. Fibonacci series using the recursion Fibonacci sequence of the number which the each number is preceding the order. The sequence commonly start the 0 1 0 1 1 2 3 5 0 8 3 program. To calculate the Fibonacci series include stdio data include variable h is 10 print inter variable inter percentage d Fibonacci n minus 2 function definition called print int n minus 1 int a 0 b c a b print f a plus d c a b b minus c fibo n minus 1 tower of Hanoi number of the step movement 2n minus 1 over the number of the disks number of the recursion call 2n plus 1 procedure move the top stack in the deep a plus b. A plus B move the disks from C move n minus 1 disks BC algorithm void main void in the tom print am tom यो यस्तो हुन्छ अनि दुइटा यता आएको हुन्छ अनि लास्टमा यता सीमा गएको हुन्छ अनि फेरि बी र सीमा एकै ठाउँ थपिया हुन्छ कता यहाँ हो अनि ए को यता हुन्छ स्टेप 4 मुभ ए टु सी स्टेप 5 मुभ बी टु ए स्टेप 6 बी टु सी स्टेप मुभ ए टु सी एबिसी. Chapter 3 Sorting is a technique of finding and checking the element from the list of the element types of sorting linear sorting, binary sorting, linear sorting, sequential sorting, linear sorting. Linear sorting each element of the list of the one of the elements sequentially and whether it is desired element or not. Algorithm index set 0 in 0 max size go to step 7 int I go to step 6, int I go to step 2, print element x found at I, period element is not found exit. Binary searching in search is given to the item in the minimum possible comparison. In search, first we have to sort the array element, then the following operation is performed. First, the find the middle of the element of the array, compare the mid element with an item. If it is desired element, then the search is complete. If it is less than the desired item, then the search is only the first half of the search array. If it is greater than the desired element, then the search is only second half is of the array. Algorithm 2 1 5 4 3 7 set big 0 0 mid 1 repeat set step 5 step if item step in the mid yields set big mid plus 1 set mid be generated go to step 2 if for step lock man yields if lock null exists in adding the data here then the data is not found example 7 9 14 24 24 30 36 42 54 60 54 initially 109 mid r mid R09 case 1 data case 2 data L minus mid 1 plus 1 mid 1 minus 1 mid minus 1 mid plus 1 element not found binary search n data in the middle return mind is data and the middle mind n plus 1 return f return element if the trace the number of the search from the following data using the binary search 10 26 33 big 5 in 6 mid 5 plus 6 by a exist trace the from the following data using the binary search 9 10 13 25 30 37 40 42 45 47 70 linear search we using the ss every element the list until the desired element is found binary search in the binary searching we don't need ss to every element it is also called the sequential search and also called the half interval search and logarithm searching the array is a non necessary before the searching the element sorting the array is necessary before searching the element. Best case is to find the element in the first position. Best case is to find the element in the middle position. Less number of the comparison, more number of the comparison are required. One of the items are present later. The later area, the more element of the present solar expression and the not difficult, faster execute and the efficient, the large data hashing is the technique of mapping the large chunk of the data into the smaller chunk using the hash table. It is also called the hash initialization types of the hashing data structure. As the step, the hash function convert the item into the linear integer hash value, and the integer used as the index to store the original data. It store the data in the hash table. You can use the hash key to locate the data quickly. Hash table compute the location of the key. It return the following value hash index as function collision property to be hidden puzzle friendly as function as k size of the table size 8 as 8 plus 1 popular types of the hash function division method, mid division method, folding method, division method. It is divided by the n k table size h k hash table mid sequence method defined by h k square where p is obtained by deleting the digit from the both end of the key tree folding element. Let the hash to be the four digit chapping the key into the four part and adding them as 5421 54 plus 275 as 5421 54210 hash table maps key to the value hashing uses the hash table to store the key value pair. It can be defined as the bucket whether the data are stored into the array format collision. The resolution technique hashing fall into the collision in if the two key are assigned into the same index number into the hash table. It forces the finding the alternate no location technique open hashing separate hashing closed hashing linear probing quadratic probing double hashing separate jamming the suppose the size of the table 10 and the key are 8 13 24 28 23 54 43 47 13 23 24 54 49 closed hashing linear probing. It is the collision that has occurred. We simply find the next location to store the it takes the a lot of time and the search key and the suppose the timetable in 10 and the key 8 13 28 23 54 43 47 function HK quadratic probing the to overcome the limitation of the linear probing size q 8 3 12 23 43 function 8 key double hashing function double hashing h0 h41 h22 h44. Find the above data stored to value into the hash table within the table position. Hashing linear probing and the quadratic probing. Quadratic probing, the chapter 8, sorting the arrangement of the sorting the arrangement of the data in a preferred order is called sorting. By sorting it is easier to sort through the quickly and easily. The simplest example of the sorting is the dictionary stable and unstable sorting, internal and external sorting, stable sorting and unstable stable sorting. And algorithm maintains the relative regard with the same key. The sorting algorithm is said to be the unstable of two or more objects with the equal key do not appear into the same order before and after the sorting. An internal sorting takes place to interleaving the main memory and the memory. This is possible when to be sorted into the small enough to be held into the main memory. External sorting can handle the large amount of data. External sorting is required when the data is being sorted do not fit into the main moving computer device and they must use the external selection sorting algorithm. Set the main location, set the minimum location element, swap the value, increment main point, the next element repeat, mean repeat, sorting unsort, sorted, unsorted, 1 2 3 4 sort, unsorted, sorted, unsorted, sorted, quick sort algorithm divide the list into the two sub lists such as that the element first is less than the same pivot key and the element in the second is greater than the pivot key and finally the sort sublist increment compile sort let us assume that the first element is pivot let us assume the first element pivot inserted pivot key let's start assume the first element pivot key as 15 pivot key second key a pivot key bubble sort each element is compared to within the adjacent element in the first element. 59. Bubble sort.
स्ट्रक्चर एन्ड अल्गोरिदमको इक्जाम छ। मैले पढेको पढेको छु तर मेरो दिमागमा के पढेछु मैले केही पनि घुसेको छैन।
Bubble sort is each element is compared with in the adjacent element in the element and the adjacent on initialize I0 repeat step 3 step 5 until I come 1 repeat step 5 until I minus 1 A I set temporary set set J plus I temporary exists 42 33 42 23 74 44 first irritation when I0 33 second irritation when I is equal to 1 first irritation I is equal to 0 irritation second irritation 25 48 37 25 48 37 25 25 25 37 32 second irritation 25 37 12 14 57 86 92 25 37 12 48 57 86 92 25 25 12 37 48 57 86 92 no irritation irritation mm, irritation sorting with the element data singly list insert the new item into the list sort the position sort is subset from the last toward the drill apply the insert and sort while sorting place the AI into the purple place. If is smaller, no change. If bigger, 15, 25, 37, 48, 57, 92, 86. 42, 63, 13, 18, 27, 3, 9, 8, 8, 81, 42, 63, 13, 18, 18, 13, 43, 13, 18, 3, 9, 8, 18, 81, 3, 19, 13, 3, 19, 13, 18, 27, 42, 63, 88, 81. Let us assume that the first element of the pivot key 13, 17, 3, 7, 22, 28, 35, 42, 42, 87, pivot key 17, 31, 7, 22, 28, 35, 42, 92, 87, pivot key 3, 7, 22, 28, 35, 42, 92, 87, pivot key 28, 37, 17, 22, 28, 35, 42, 92, 87, pivot key 35, 3, 7, 17, 22, 28, 35, 42, 92, 87, pivot key 42, 3, 7, 17, 22, 28, 35, 42, 92, 87, pivot key 92, 3, 7, 17, 12, 28, 35, 42, 87, 92. Space complexity of an algorithm represents the amount of the memory space needed. The algorithm is to be life cycle space needed by an algorithm space needed by the fixed part of the space needed by an volatile part space complexity sp of any algorithm p is an sp and a plus p where the a is treated as a fixed part and the s1 is treated as a variable algorithm sum plus pq sum plus state 3 p plus 1 state 3 variable a and 1 constant. The complexity of an algorithm represents the Rotation of the output time required by an algorithm is executed to the component. The requirement can be obtained in the number of algorithm or the and can be measured as a number of the steps provided. Each step takes the constant time. For example, the case I addition to bit integer. If n step are taken consequently, the total computation time NB or NC is called the time consumed of the addition. Types of the asymptotic rotation, big notation, it defines the upper bound of the function, i.e. maximum time taken by the algorithm. The worst case complexity of an algorithm, big omega, it defines the lower bound of the function, i.e. the minimum time taken by an algorithm. Big zeta notation or average, it defines the lower end and upper bound function. It exists into the both in the most boundary for given input data. Bubble search selection insertion modes quick if counting radic bucket bucket n minus kon, it is divided into the concurrent approach. It consists of the two phase partition of the list into the two halves until the list size is one more. The strategy is sub list phase 1 25 57 48 37 12 92 86 33. Radix sort is the non-comparative integer sorting the algorithm that sorts the data with the integer key by the individual digit, which can be done the same significant position in the value 175 70 85 81 283 221 22 22 175 170 085 131 283 221. First digit position 70 181 221 002 022 283 175 085. Passing second digit. Third digit pass one 040170210161121601100260110020010010140161110 170 using the more search 38 27 43 39 82 10. Solution 38 27 48 39 82 10 38 27 48 39 82 10 38 27 48 39 82 8 38 27 48 39 82. Page second 38 27 42 39 82 10 30 27 38 3 4 9 62 3 27 38 48 3 9 8 22 10 82. Assignment. What is the data structure and the DSA explain the class friction of the data in D tree and the big notation. What is the doubly linked list? Doubly linked list is an algorithm we build and help using the given element. We create a max heap and the sort of the element in the ascending order. Finally, we swap the root node with the last node and the delete the last node in the from the heap. Max heap, minimum heap, parent node, children node, parent node, child node, build heap, balance binary tree, balance binary tree 18 5 15 8 25. Create the max heap 10 15 8 25 5 15 10 8 25 5 15 25 8 10 5 25 15 5 10 5. Swap the root with the last node 10 and delete the last node 10 5 15. Sorted array.